Hello everyone and welcome to another video. Today I'll be recording a video on the derivatives of trigonometric functions. So let us proceed. So first I'll write all of them down so you can kind of get an idea. So the derivative of sine, so if you have sine x is equal to cos x, right? The derivative of cos x is equal to minus sine x. The derivative of tan x equal sec squared x, and the derivative of yeah, I think we can just stay here for a little bit. For these videos are for CAPE level, so really I'm just trying to get what mostly comes for CAPE. Of course, there are other things, but the thing is, right now I'm making a video on differentiation and not trigonometry, and other things like sine ax plus b is equal to a cos ax plus b, where a and b are constants. Like these things, you'd probably understand if you do trigonometry, and I haven't yet covered trigonometry on this channel, so I don't want to do a topic where I haven't even covered myself, like on the channel. So I'll wait until I cover that and then I'll go over some extended standard derivatives of trigonometric functions. I'll do another video on that after I cover trigonometry. But yeah, I don't want to make a video before I actually cover the topic. So yeah. So these are the standard derivatives of trigonometric functions, and yeah, just kind of learn them. Uh, There's not much else to do about that. I mean, you could learn how to derive them using the first principle, but yeah, I mean, it's whatever. Try to learn them. So let's use problems now. So let's say we have y is equal to 2x. Well, why did I put it in there? Y is equal to sine of 2x plus pi over 4. How would I find y prime? So to do this, we know that the derivative of sine is cos right there. We know that. So if that's the case, then wouldn't this just be cost, right? Like you're probably wondering, like, well, how hard could it be? I mean, yeah, but this is actually not the case. So it's not just going to be cost because we have to divide. No, sorry, not divide. Derive the parameter as well. So what's going on is that we're going to treat this as though it's a product rule problem, right? Wait, not product rule, sorry, chain rule problem. It is a chain rule problem actually because we're going to have to differentiate parameter as well. So it's like we're differentiating the outside and the inside. Where the outside in this case is going to be sine and the inside is going to be 2x plus 4. So the derivative of sine is equal to cosine. So we'll say cos, and then we'll say cos of the 2x plus 4 plus pi over 4, sorry. And then we'll multiply it by the derivative of the inside of the bracket. And the inside of the bracket has 2x plus pi over 4. And please note, pi is a constant. So the derivative of pi is going to be 0. Regardless of if it's divided by 4 or whatever, right? It doesn't matter, it's going to be 0. And the derivative of 2x is equal to 2. So it's going to be that times 2. So the derivative of sine, oh, my HP, I should probably have put do not disturb on. But regardless, we will move. So this is equal to 2 times cos of 2x plus pi over 4, right? Looks difficult because it has pi in there. I get it, it looks kind of difficult, but you kind of get the hang of it, right? Eventually these will become second nature and you'll never have to think about them again, right? So yeah, let's just try. Okay, so let's see if we have. Oh, and this is just the answer, by the way. Like I forgot to state that this is just the answer. Like very simple. If you know these general, I guess what do you call them, standard derivatives, then you're well on your way. Sine equals derivative of sine equals cos x. I guess I'll just put a sine y and, oh, let me put it in a different color actually. We have y and y prime. That looks good. Okay, let's go on to another question. So let's say we have, I don't know, we'll have y equals cos of 2x minus pi over 8. And I want you to find the derivative of this, right? So how do you find the derivative of that? So remember, it's like a chain rule problem. So we'll find the derivative of the outside. So the derivative of cos is equal to what? So we scroll up back to the table. Derivative of cos is equal to minus sine. So we'll say it's equal to minus sine. Put by the inside, which is called the parameter, 2x minus pi over 8. And then we'll multiply it by the derivative of the parameter, the derivative of the inside, which is going to be equal to times the derivative of 2x is equal to 2, so times 2, because pi over 8 cancels because it's a constant, which is equal to 0. So this will be equal to minus 2 sine of 2x minus pi over 8, right? And it's something pretty simple, right? So we'll just do a couple more examples and, very basic. Of course, these can get more difficult because they'll ask you to do a bunch of like garbage, but for now, with just reviving it, it's actually going to be fine because you're not doing any hard questions. Yes, when you have second derivative, third derivative, or like further down the line, it's going to become a little bit more difficult, but we'll get through it. So let's say f of x is equal to um we'll say it's equal to x squared times tan x, right? So how do we find the derivative of this? So this is actually like we're using so this is actually what we're doing. We're using product rule and chain rule in the same thing. So these differentiation of trigonometric functions questions, they can get a little bit difficult because they'll start using everything together with like every rule together and gets kind of heated a little fast. But nevertheless, let's continue. So this is equal to, when multiplying by two things that can't like cancel each other, like this, we'll use product rule. So product rule states that we'll have d by dx of whatever, so we'll say x squared times tan x, and it will add x squared times d by dx of tan x. So this will be equal to so the derivative of x squared is going to be equal to 2x times tan x plus x squared, and the derivative of tan x is going to be equal to sec squared x. Now, this would have been really a little bit, just a tiny bit more annoying if there was a parameter um, over the tan x. Like, so instead of just tan x, it could have been tan 2x, tan 3x. It would have been just a little bit more annoying, but you'd have been able to do the same thing anyway. I'll give you a question with that soon, so you'll kind of get the hang of it, right? So now, we'll just make this a little bit more clean. It's going to be equal to 2x tan x. And I will say that's plus x squared sec squared x. And that's your answer right there. That is the answer, right? So hopefully you're starting to get the point and like get it by now. Yeah, let me continue going on with some more examples. I guess I have more space on here, I'll use it. So let's say we have y equals to, let me think here. Let's see, you have y equals sine of 3x plus 2 And then, yeah, how do we find the derivative of this? Well, actually, no, that's too easy. Sine 3x plus 2, and then we'll divide it. Actually, no, if we divide it, we might get some other trigonometric function. So we'll just leave it by that. Like, okay, right? This is equal to what now? So the derivative of sine is equal to cos. So it's going to be, so we're going to write backward cos, and then we're going to write back the parameter, which is 3x plus 2, multiplied by the inside of the inside, which is the parameter. So in here, so multiplied by that is going to be equal to times 3. So it's equal to 3 cos 3x plus 2. Right, so hopefully you're getting the hang of it by now. These questions are not hard, and you should probably be able to get them soon, right? So I'm hoping you're getting it, but let's nevertheless, we'll continue going. Okay, so yeah, let's try a little bit harder question. Let's see why. Let me just make sure I'm in line here. Guess that's fine. Say y is equal to cos x times tan 2x. How would we find the derivative of this? So we would say this is actually the product rule now. So in order to do this, we'd say d by dx of cos x times tan 2x, and then we'll add that to cos x times d by dx of tan 2x. Okay, because this is just a product rule, and we're just outlining what we have to do eventually. And yeah, let's continue. So the differential of cos x is actually um just minus sine x, and we'll multiply that by tan 2x, and this is being added to cos x times. So the derivative of tan x is sec squared x, but this is tan 2x. So if it's tan 2x, we'll treat it as though it's a chain rule problem, which it is chain rule actually. So I don't know why I said treat it that. It is chain rule. So we'll say times tan. Oh, sorry, sec squared, because the derivative of tan x is sec squared. And remember, we leave the parameter, so sec squared 2x times the inside of the parameter, which is the parameter in this case is 2x. So inside that times 2. Right? So this is going to be equal to minus sine x tan. Wait, am I lost? I'm not lost. Yeah. So yeah, minus sine is tan 2x plus 2 sec squared x cos x. And yeah. Oh, 2 sec squared 2x. Sorry, I see. I'm missing a parameter myself. Yeah, it happens. So try not to make the same mistake as me. I need to fix this. This looks kind of derpy. 2x. Right. And yeah, pretty much pretty much it. That's just the answer. It's not too hard at all. I'll do one more because I think this one's a little bit different and I just want you to kind of get it. So we'll say y equals sine cubed x, sine cubed of 3x. So this is the same thing as saying it's equal to sine of 3x all cubed. And now to find the derivative of this, we know it's going to be equal to the chain rule. So it's going to be, we'll bring the power down. So bring the power down in front of it, right? So it should leave us with 3 times what's inside the bracket, sine 3x, and then 3 minus 1, which is 2, and then multiply by the derivative of the inside the bracket. So, but this is another chain rule problem, so it gets a little bit more complex. So the derivative of sine is equal to cos, so it's going to be cos of 3x times the parameter, which is 3. Well, the derivative of the parameter, which is 3. The parameter itself is 3x. And yeah, we'll just kind of make this a little more time. So it's going to be equal to 3 sine 3x. 3 minus, sorry, this is 3 minus 1, sorry. Because it should be 2, yeah, it should be squared. Times 3 cos 3x. And yeah, so this is just equal to 3 cos 3x 3 sine 3x squared, which is then equal to 3 cos 3x times 3. Oh, what kind of 3 is that? 3 sine squared 3x. And yeah, that's just it. So I hope you've understood what I was trying to explain in this video, and if you did, I hope you enjoyed the video. And if it didn't work for you, try other videos, keep trying, don't fail, and good luck on your tests or whichever it is that you're using. And yeah, I'll be making another video tonight. It's now 8:50. I have school tomorrow, but I'll make one more video. I think on higher derivatives, and then I have to make a video on first principles and applications of differentiation, and we should be good. I'll also make a video I'll probably make a video showing people how to do their SBA. But yeah, I hope you enjoyed the video. If you did, I'm very glad, and hopefully you learned something.